The next one is going to be the change in y over the change in x. And the change in y is 2 over 1, which is 2. Awesome! That means that both of these are the same. That's exactly what we need, but we need it to be the same for all 4 of these. Let's see. So far we have 2. That is great. Okay, on to the green. Rate of change. The change in y over the change in x equals, the change in y is 2 over the change in x is 1. And yes, 2 divided by 1 is 2. So we have another one that is exactly the same. Perfect. That's 3. On to the last one. So we have the change in y over the change in x, which means, what does it mean? It is equal to the change in y is 4 over the change in x is 1. So 4 divided by 1 is 4. And that is not the same. That's not 2. That is 4. Ah! This is the one that messed it all up. So what that means is even though there's 3 that are the same rate of change, this one is not the same. So this is not linear data. This is some other type of data. So what we can say is we can say the rates of change, I'm just going to say vary. Okay? They vary. They're not the same. The table, right, all of this, the table shows non-linear data. And a nice little cloud. Okay, so hopefully you got that right. If you did, great job. Okay, we are on to the next problem, right over here. Okay, let's look at the rates of change again. So the first one from 0 to 1, I want to say that that is 0 plus 1. That's how we get 1. Now what's happening from 1 to 4? Well, we're going 1 plus 3 equals 4. What about from 4 to 6? 4 plus 2 equals 6. And what about from 6 to 9? 6 plus 3, oh, come on, blue. 6 plus 3, that's a plus 3. Oh, there we go. 6 plus 3 is equal to 9. Okay, and then on to the y's. We have, what's happening here? What's the change? Well, 0 plus 2 is 2. What about from 2 to 8? Oh, 2 plus 6 is 8. That's kind of interesting. And what about from 8 to 12? That would be 8 plus 4 is 12. 8 plus 4 is 12. And lastly, what's happening from 12 to 18? Well, 12 plus 6 is 18. All right, now it's time to find each rate of change and see if they're all the same. Okay, the first one we're going to look at is the rate of change equals the change in y over the change in x. So the change in y is 2 over 1, which is 2. All right, let's do the next one. The change in y over the change in x. The change in y is 6. Oh, equals, forgot my equal sign, is 6 over 3. 6 divided by 3 is 2. Oh, all right. Those two are exactly the same. That is awesome. Okay, on to the next one. Rate of change, the change equals the change in y over the change in x. The change in y is 4 over the change of x is 2. 4 divided by 2 is 2. Hey, there's another one. 2, 2, 2. So far, all the rates of change are the same. Let's see if this last one can come through for us. So lastly, the rate of change is the change in y over the change in x. And what do we have for the change in y? We have that it is 6 over the change in x is 3. 6 divided by 3 is 2. And woohoo! Yes, they are all correct. Awesome. So what we can say is the rate of change is constant. That means it is the same. It's 2, 2, 2, and 2. The table shows linear data, which means that this table, if we plotted all of these wonderful points in ordered pairs, they would all connect up to this straight line that's linear. All right, if you got it right, great job, and we will see you next time.